Hello friends, welcome to Defense Matrix. On this channel you will get fully information about defense and technology. Let's view the video. America's real-life Iron Man suit. The birth of the Iron Man dream. DARPA's bold vision in the early 2000s, while Hollywood mesmerized audiences with the high-tech exploits of Tony Stark, deep within the Pentagon's futuristic research. Wing, DARPA, Defense Advanced Research Projects Agency, engineers and visionaries were planning something that would blur the line between fiction and reality. The question was bold. What if our soldiers could wear armor that made them faster, stronger, smarter, and harder to kill? For DARPA, it wasn't just about fantasy. It was about survivability on the battlefield, especially for U.S. Special Operations Forces conducting dangerous missions deep behind enemy lines. Too many soldiers were being lost in close-quarters combat or during high-risk extractions. The answer? A revolutionary combat exosuit that could enhance human capability, an idea inspired as much by necessity as it was by sci-fi. This dream wasn't born overnight. For decades, DARPA had been experimenting with robotic limbs, artificial muscles, and smart materials. But by 2013, something changed. Then SOCOM, Special Operations Command, Commander Admiral William McRaven issued a challenge that would accelerate the effort. Can we build a suit that will provide total ballistic protection, enhanced strength, and integrated weapons and sensors for our troops? This was the moment the Iron Man dream became a military directive. Within months, DARPA began working with top universities, tech startups, defense giants like Lockheed Martin, and innovators from Silicon Valley. The goal: combine advanced robotics, liquid armor, wearable computers, and augmented vision into a single suit, the first step toward a real-life superhero soldier. The media dubbed it the Iron Man suit. But for DARPA and SOCOM, it was known by another name, Talos, the Tactical Assault Light Operator suit. And what followed was one of the most ambitious military tech races in modern history. Talos, the Tactical Assault Light Operator. Suit Talos wasn't just a suit. It was a technological revolution wrapped in armor. From the outside, it looked like something ripped straight out of a Marvel movie. A sleek, powerful, human-shaped exoskeleton designed to give a single soldier the power of 10 men. But under the surface, it was even more impressive. The vision behind Talos was to create a suit that could do it all. Think of it as a mobile command center, life-saving medical unit, and armored tank, all worn like a second skin. At its core was powered exoskeleton technology, engineered to multiply a soldier's strength and endurance. Operators could carry over 200 pounds of gear without strain, sprint across open ground without fatigue, and even leap and climb with robotic assistance. Think of soldiers kicking down doors with superhuman force or lifting wounded comrades with but Talos didn't stop there. DARPA partnered with MIT and other research institutions to develop liquid body armor, a material that remained flexible until struck, at which point it hardened instantly. This meant full-body protection that moved like fabric but could stop bullets on impact. Inside the helmet, developers integrated a heads-up display with augmented reality, night vision, and target tracking AI. Soldiers would no longer need to look down at maps or radio in for support. The suit provided real-time data, enemy locations, and mission updates directly in their line of sight. Even more impressive, the suit included internal sensors capable of monitoring vital signs and injuries. If a soldier were shot or wounded, Talos could automatically administer life-saving first aid, inject painkillers, or signal for medevac. The goal was clear: 0 deaths in the first hour of trauma, with over 50 companies and 16 government agencies contributing to the design. Talos became a melting pot of American innovation. Engineers, biologists, software developers, and robotics experts worked together in a massive push to bring science fiction into reality. But for all its promise, Talos wasn't without challenges: power supply, weight, battery life, environmental adaptability. Integrating all of these cutting-edge technologies into a wearable platform proved harder than anyone imagined. Still, the dream was alive, and the future of warfare was changing, one line of code and steel joint at a time: power, armor, and augmentation. Breaking human limits. Creating a real-life Iron Man suit wasn't just about adding armor plates and calling it futuristic. It required redefining what the human body could do, and then engineering machines to do it better. At the heart of Talos was the powered exoskeleton, a biomechanical framework worn over the body, designed to amplify strength, speed, and endurance. Each step, each lift, each movement became smoother and stronger with hydraulic and electric assist. Soldiers could run faster, carry heavier loads, and perform physically punishing tasks with superhuman efficiency. But this raised a fundamental question. How do you power a supersuit in the field? Powering Talos was one of its greatest engineering hurdles. The suit required an energy-dense, lightweight battery system capable of supporting hours of combat movement, sensor feeds, cooling, systems, and communications. DARPA explored advanced lithium-ion batteries, fuel cells, and even energy-harvesting fabrics. The dream was a suit that could self-recharge while on the move, but the technology wasn't quite there yet. Next came the armor, traditional body. Armor is heavy, rigid, and limits mobility. Talos aimed to replace it with liquid armor, a new class of material made from shear thickening fluids. These materials stay flexible during normal movement but instantly harden upon impact, providing a blend of mobility and ballistic protection never seen before. Imagine dodging bullets with armor that flows like cloth but solidifies like steel when it matters most. Then came augmentation, the neural and digital enhancements that would take soldiers beyond their natural limits. Integrated biosensors tracked everything from pulse to hydration levels, while built-in AI systems processed terrain data, enemy movements, and mission objectives in real time. A single operator could become a one-man tactical unit, aware, protected, and empowered with battlefield data and robotic strength. Eye-tracking systems controlled the helmet display. Advanced ear protection filtered harmful sounds while enhancing quiet footsteps. Heat sensors identified hidden enemies behind walls. Every inch of Talos was designed for total battlefield dominance, but the tech wasn't just for combat. Future. Applications of Talos components are being explored for disaster relief, search and rescue, and industrial safety. In many ways, Talos represents not just the future of war, but the future of man-machine evolution. Challenges of creating a super soldier. With all its promise and innovation, the road to America's real-life Iron Man suit was anything but smooth. The first major obstacle? Power and energy management. While Talos required substantial power to run its systems, motors, sensors, AI processors, it also had to remain light enough to be mobile. Engineers were caught in a paradox. More power meant more batteries, and more batteries meant more weight. This delicate balance became a continuous source of frustration for designers. Then came mobility and weight distribution. As new components were added, cooling systems, AI processors, reinforced joints, the suit became heavier and more complex. Every additional ounce of weight risked compromising the operator's agility and effectiveness in combat scenarios. Developers introduced advanced materials, including titanium alloys and carbon composites, to keep the weight down without sacrificing strength. But even with the best materials, the suit had to be worn, not just tested in labs. Operators in early prototypes often reported overheating, fatigue, and limited movement, serious issues in the chaos of real-world warfare. Another major challenge was integration. It's one thing to build a powerful exoskeleton. It's another to make it work in harmony with the human body. Engineers needed to synchronize machine movements with the operator's every step, bend, and reflex, without lag, without resistance. This meant real-time biomechanical feedback, AI-assisted motion, control, and seamless neural interfacing. And then came safety. What happens if the system fails mid-mission? What if a sensor misfires or a motor locks up during combat? A malfunction could leave a soldier immobile, or worse. Fail-safes, emergency release mechanisms, and manual overrides had to be designed and tested rigorously. Beyond the technical, ethical questions loomed large. If one nation could create super soldiers, what kind of global arms race would it ignite? Would other countries respond with their own exosuits, autonomous drones, or AI-directed troops? How would laws of war evolve when machines started sharing the battlefield with men? Despite over 80 million in research and years of development, Talos never fully met its original battlefield goal, but it wasn't a failure. It was a blueprint. The lessons learned are now shaping next-gen technologies, from the U.S. Army's IVAS system to experimental robotic combat units. Talos was the first step in a long march toward the future of war, a future no longer ruled by imagination but by innovation. Future warriors, how close are we to Iron Man? Today, the dream lives on. While Talos may have ended as a prototype, its technologies are now embedded in projects across the Pentagon. The U.S. military is actively testing lighter exosuits, AI-guided, helmets and smart armor systems, robotic muscle fibers, brain-computer interfaces, augmented battlefield reality. We may not see soldiers flying like Tony Stark yet, but the super soldier revolution has already begun. And in the next war, they may not just fight, they may dominate. Thanks for watching. Subscribe our channel Defense Matrix for more interesting and knowledgeable videos.